Question number 2, how would you make up 500 milliliter of a 100 milliosmolar of NaCl solution? This is very similar to the first question in this workshop. The only difference being that instead of giving you a certain molarity, it's giving a certain osmolarity. So the first step is that we are going to convert the osmolarity into molarity. The formula of osmolarity is osmolarity equals molarity times the dissociation constant of a solution. If we assume complete dissociation of NaCl in this question, then the dissociation constant of NaCl should be 2. So we can have molarity of NaCl equals 100 milliosmolar divided by dissociation constant, which is 2, and then we get 50 millimolar as the molarity of NaCl. From the molarity of the solute and the definition of molarity, if we multiply the molarity with the volume of the solution, we can get the moles of NaCl that's needed to make this solution. The final number is 25 millimoles. That's the amount of NaCl that's needed to make this solution. From the moles of NaCl, if we can multiply this number by the molecular weight of NaCl, then we can find the weight of NaCl that's needed in the unit of grams to make the solution. The type of solutions that we use to solve this type of problems is always going to be the same. Ultimately, we need to have the weight of the solute and the volume of the solution in order for us to have a certain osmolarity or certain molarity of solutions. Since the volume of the solution sometimes is given, so the most essential part for us to do is to find the weight of the solute. The weight of the solute normally comes from the moles of the solute, how many moles that you need to make the solution. And the moles of the solute comes from the molarity, and molarity comes from osmolarity. So the trick is always use the formulas reversely. You need to understand the formulas very well in order to use them reversely, but when you get used to it, you understand this is not a hard type of question to solve. Question number 3 is if you understand that the dissociation constant of NaCl is close to 2, slightly lower than 2 instead of a perfect 2, instead of using a dissociation constant of 2, but using with the dissociation constant of 1.8, how would you do the calculation? The calculation process will still be the same. Just you substitute the dissociation constant with 1.8. So I'll leave that to your own.